Hello everyone, welcome to my channel CISC Topper Classes. Today we are going to discuss chapter 10 exercise 10.3 question number 10 to 15 of ML Aggarwal class 9 mathematics. So let us start solving this exercise here in this video. If you like this video, please like, share and subscribe my channel. Now let us solve the 10th question here. In the adjoining figure, AD, BE and CF are altitudes of triangle ABC and AD and BE and CF are equal. Then we have to prove that ABC is an equilateral triangle. So firstly we will take two triangles. Now in triangle BFC and triangle BEC, we have to prove the congruency. So we have here FC is equal to CF is equal to BE as given here. CF is equal to BE. This part is given and BC is common here. BC is common and we have right angle here. So this is the right angle means angle BFC is equal to angle BEC which is equal to 90 degree from right angle. Now we can simply say that here this is angle BFC is equal to congruent to angle BEC by SSA means side or RHS rule of congruency. We can say that right angle hypotenuse and side rule of congruency. So from here we can prove that these two angles are congruent. Similarly, in these two angles also we can say that in triangle ADC and triangle A, here we can say AOC. So a triangle AOC also we have. So similarly we can say they here as here this is angle A FC. So in these two angles, similarly we can prove that these are also congruent. Angle triangle ADC is congruent to angle AFC from here. Now we can prove that ABC is an equilateral triangle. As these are equal, we can say that angle B and angle C are also equal, from where we can prove only that angle AB, side AB is equal to side AC. So if angle B is equal to angle C, we can prove that AB is equal to AC. And similarly in this also we can prove that here this is the first thing. Second thing we can prove from this triangle as if angle A is equal to angle C, we can say that angle AC is equal to angle AB. This is the second thing. From this only we can prove that AB is equal to AC and AB is equal to AC and AC is equal to BC. From here, this is proved that this is an equilateral triangle. Means triangle ABC is an equilateral triangle. Now let us solve 11th question here. In a triangle ABC, AB is equal to AC, D and E are points on the sides AB and AC respectively, such that BD is equal to CE. Show that triangle DBC and triangle ECB are congruent. Simply from the here, the given information is BD is equal to CE, means this is given to us. BD is equal to CE and BC is common here in these two triangles. Simply the third part is AB is equal to AC. From here we can conclude that angle B is equal to angle C, as angle opposite to equal sides. Opposite to equal sides are equal. So from here we can write as angle BD side angle side congruency. So we can simply write triangle DBC is congruent to triangle ECB. So this is by side angle side rule of congruency we have this. Now let us solve the second part. Means we have to prove, this is the first part which we have proved here. By CPCT we can prove that angle DCB and angle EBC are equal. So here we have DCB equal to angle EBC are equal means this is from CPCT we have here. Now, the third thing which we have to prove is OB is equal to means uh, OB, where O is the point of intersection of BE and CD. We have OB is equal to AC. From here, we can simply prove that we can firstly we will prove that these two angles are equal. From here, given information is BD is equal to CE. So in this part, we have proved this as equal. This is given only to us. Now, the second thing which is equal, we can say, is this angle, which is BDO is equal to angle EOC from here, because by congruency also we can prove this part, and because CPCT is there means BDC, if this is equal to BEC by CPCT angle BEC, so BDO is also equal, and here CEO is also equal. Now we have DOB here, angle DOB and angle EOC. This is by CPCT here we have, and this is vertical opposite angle here. So these are vertically opposite angle, that's why they are equal. Now from triangle DOB is equal to congruent to triangle EOC from here by angle and side congruency means here by side angle side rule of congruency we can prove that these two triangles are congruent, and from here only we can say that OB is equal to OC by CPCT, which we have to prove here. So this is the final thing which we have to prove, hence proved from here. Let us solve the 12th question here. ABC is an isosceles triangle in which AB is equal to AC and P is any point in the interior of triangle ABC such that angle ABP and angle ACP are equal. Then we have to prove that BP and CP are equal. So firstly we will join the point here. So BC and here BP and here CP. So similarly, we can write it as, firstly we have to prove that BP is equal to CP. To prove this, we can take triangle um, in triangle ABP and triangle ACP. We can see that AP is equal to AP, which is common here. Now it is an isosceles triangle, so AB is equal to AC. This is also given to us, and angle ABP is equal to angle ACP. This is also given to us. Angle ABP is equal to angle ACP. This is also given. As this is given, we can see that triangle ABP is congruent to triangle ACP because by um, angle side congruency. So it will be angle side rule of congruency here. So by this we can prove here that BP is equal to CP by CPCT from here. Now the second thing is, this is the first part which we have to prove, and here the second part is AP bisects angle BAC. From here also by CPCT, because of the congruency of these two triangles, we can find that angle BAP is equal to angle CAP by CPCT. So hence proved from here. Hence proved. Now let us solve the 13th question. In that joining figure, D and E are points on the side BC and the triangle ABC such that BD is equal to EC and AD is equal to AE. Then we have to show that triangle ABD is congruent to triangle ACE. So simply we can write firstly that if these two sides are equal means this angle is equal to this angle, and from there only 180 minus this angle will be same here also, ADB is equal to AEC. So to prove this we can simply write that angle ADE is equal to angle AED because the two sides are equal and opposite angles of equal side are equal. So from that we can see here and here angle ADE minus here 180 degree, if we subtract from this, is equal to 180 degree minus AED. We will get here as angle ADB because this is a straight line, and here angle AEC. Now the given information is BD is equal to EC here. This is given and this we have proved here. And again AD is equal to AE. AD is equal to AE. This is also given in this question. From here we can prove that triangle ADB is congruent to triangle AEC, and this is by SAS rule of congruency, side angle side rule of congruency we have proved here. And this only we have to prove here, hence proved from here. Now let us solve 14th first part. In the figure given below, CDE is an equilateral triangle formed on a side CD of a square ABCD. Then show that triangle ADE and triangle BCE and hence AEB is an isosceles triangle. So for proving this, firstly we can write here as um, we have to prove that ADE is equal to BCE. So here we have, because this is ABCD is a square, means AB is equal to BC is equal to CD. From here we can write AD is equal to CB. So this is given to us, and here this is an equilateral triangle. From here we can write DE is equal to CE. This is also given to us, and here in a square we have this angle as 90 degree, and in an equilateral triangle this angle as 60 degree. So from here we can write angle ADE equal to angle uh, ADC. We can write angle ADC plus angle CDE. So this will be 90 degree here plus 60 degree. So adding this we will get 150 degree here. So here only, this is also the same thing. Here also this is 90, this is 60. From here we can prove that angle ADE is equal to angle BCE. And hence from here we can prove the congruency, because it is first and it is second and it is third part. From this we can prove that triangle ADE is congruent to triangle BCE by SAS rule of congruency. So by using this rule of congruency, we have proved that these two angles are congruent, which is asked in this question to prove. And according to this only, we have to prove that AE um, and ABE is an isosceles triangle here. So to prove that AE and ABE is an isosceles triangle, we can simply write, because ADE and BCE triangles are congruent. So from CPCT we can write AE, side AE and side BE are equal from CPCT, and hence if the two sides are equal here, we can say that this angle is also equal. Means if two sides are equal, it is an isosceles triangle. Hence proved from here. Hence proved that triangle AEB is an isosceles triangle. Now let us solve the 14th second part here. So in 14th second part it is given that O is a point in the interior of a square ABCD such that OAB is an equilateral triangle, so that OCD is an isosceles triangle. So simply we can write here as OA is equal to OB, means this is given here. So OA is equal to OB because it is an equilateral triangle, and AD is equal to BC because it is an square here. So this is also given because of square. Now as this is equal to 90 degree and we have this as equilateral triangle, so this will be 60 degree and this whole will be 90 degree because of a square. So simply we can write as angle O OAD is equal to 90 degree minus 60 degree, which will be 30 degree, and which is equal to angle CBO. So this is angle CBO. So hence proved, here we have proved. Now by SAS rule of congruency we can say that OAD is congruent to triangle OCB by side angle side rule of congruency. So hence proved from here. And we have to prove that OCD is an isosceles triangle. So from here we can say that OD is equal to OC by CPCT, and hence we have OC is equal to OD. Hence this triangle OCD is an isosceles triangle here. Hence proved. Hence proved from here. So this is the final answer. Now let us solve the 15th question here. In the adjoining figure, ABC is a right triangle with AB is equal to AC, and bisector of A meets BC at D. Then we have to prove that BC is equal to, this BC is equal to 2AD. So here in right angle triangle, angle A is equal to 90 degree and AB is equal to AC. So from here we can say that angle B is equal to angle C, which is 45 degree. Here B plus C is 90 degree. Because these two sides are equal, we can say that these two angles are also equal. This is 90 degree, we will calculate, we will get 45 here, and AD is bisector of angle A. So simply we can say that DAP and DAC is equal to 45 degree, because these two angles are equal, and 90 divided by 2 will be 45. Now in triangle ADB, we can say that DAB, here this DAB is equal to angle B, because this is also 45 degree, this is also 45 degree, and from here we can conclude that AD is equal to DB, and similarly we can prove in the case of ADC also. This is also same as AD. This AD is equal to DC, because these two angles are equal. And similarly we can see that AD is equal to DB here, and AD plus AD we can say 2AD, and DB plus DC, and here BD plus DC. We can also say DB plus DC and BD plus DC also. So it will be BC here. So similarly, we got it as BC is equal to 2AD. So this is the final thing which we have to prove. Hence proved from here. Hence proved here. So this is the final thing here. Thank you for watching my video. If you like this video, please like, share and subscribe my channel.